Hi, today I want to show you how serial justice works well together with AI, and in particular how it can be used to define the carbon footprint of plane travel. AI is very good at generating content. However, there are two main issues with it. First of all, the content produced by AI is not the truth, but only patterns which resembles human-produced content. Furthermore, because AI produces content much faster than humans can process it, there is a risk of disruption which might force humans to use information produced by AI without human verification. Serial justice can address both of these issues because it brings humans in the loop of defining common understanding, what we in French call entendement, but it does so in an efficient and scalable way, which helps to mitigate the disruption of AI. First of all, we need to add the airplane tool. So let's do this. Okay, now we can add a version. And the version I propose is an A320 in economy. And for the parameters, I propose obviously to specify the distance in kilometers, which is a float, and we can say that it's the distance of the flight in kilometers. And we can also add another parameter, which is the passenger ratio. And the unit, I propose to say it as a ratio, and it is a float as well. And we can say, well, it's the ratio of how many persons are in the airplane versus the airplane capacity. So, for example, if the plane is only half full, the plane travels and uses more fuel. And let's add an image. Okay, we added the tool. Now we can request a vote. And here I suggest not to add a comment. It's possible to add a comment and maybe propose an answer or hints about the answer, but it's not necessary. And if we look at the next voter, we see this address. So we can switch to that account to see what he should do. And he is requested to answer this tool. he can have a look at the parameters. And probably the person who has to vote is not an expert. So here comes the ChatGPT-like AI, and he might do some research. So this is text from an AI, and he asked how to estimate the CO2 emissions of flying in economy class and with an A320. And the AI proposes a formula which takes into account the distance of the flight and the fuel efficiency of the aircraft. And for the A320, the efficiency is approximately 3.5 liters per 100 kilometers. And as well the number of passengers of the flight. And to define the passenger ratio. And yes, the proposed formula takes the distance, the fuel efficiency, and the CO2 emission factor. And the CO2 emission factor converts the carbon content of the fuel into CO2. So, and this is not dependent of the plane, but it's more dependent on the fuel. And it also provides a value for the CO2 emission factor. And here, this is the passenger ratio, the number of passengers over the passenger capacity. And this is what the formula that we have. But there is actually an issue with this formula. And we can see it as humans, because if there is more distance, the CO2 emissions get higher. If the fuel efficiency is higher, then it consumes more. But actually the fuel efficiency is the fuel consumption. So if the value is higher, it consumes more per kilometers. So this is normal. And the CO2 emission factor, if it increases, the CO2 emission increase. But here we multiply with the passenger ratio. And it means that if there are 0 passengers, there are 0 emissions, which is not true. So the failure here is that it should be dividing by the passenger ratio instead. So here we can write to the AI that's probably wrong, and actually it apologizes. But yes, it helped us to get a formula. And now we can define a script using that formula. Let's define the fuel efficiency as 3.5 liter for 100 passenger kilometer. And this depends on the airplane. Let's define the CO2 emission factor to be 3.16 kilogram CO2 equivalent per liter. And this is a typical value for the jet fuel. and then the CO2 emission as the product of distance divided by 100 times the fuel efficiency times the CO2 emission factor divided by the passenger ratio, and then return for the CO2 the CO2 emission value times 1000, because the CO2 emission is in kilograms and we are counting in grams. So we have the script. I will not write the justification here because I already explained it. Once we have done this, we can create an item for the airplane travel. And we can add a particular version. And I propose from Paris to New York, or Paris, New York. Works both ways. And for the step, we have only one step, which is the flight. We can specify the tool and the parameters. And for the distance, I had a look, and it's 5,834 kilometers. And for the passenger ratio, let's say it's 1, which means that the airplane is full. Okay, let's add the item version. And see the process that we made with this particular tool. And if we look at the algorithms, we can see this value, which means 645 grams of CO2 equivalent for the airplane travel. So this is amazing. We just created an algorithm for the carbon footprint of air travel, and we can use it to compute the footprint for different flights. But this is only an algorithm, a subjective algorithm, and there are so many ways of appreciating things, so many things we can choose to consider, not to consider. So at this stage, it is just a proposal. It might evolve depending on the needs. And in this particular case, it might happen that any member thinks that the algorithm could be improved because, for example, the fuel consumption of airplanes is not the same for short flights as for long flights. And this is because in the high altitudes, the plane is more efficient. And therefore, shorter flights consume more fuels. So if someone would like this to be taken into account, he can propose this and he can say, well, and just do a comment and request a vote. Now, the person who has to vote has access to the justification that I explained and then this request. So he can look at it and he can again ask an AI about it. So how to take into account that the fuel efficiency is dependent of the flight distance. And the AI says, yes, it's true, it can change. And it proposes a simplified approach to take this into account and proposes to use a correction factor for shorter flights. The value is 125. So the result should be multiplied by 125. For medium flights, it should be multiplied by 110. And for long flights, it can be multiplied by 1, so it would not change. And so if the person agrees with this, he can have a look at the script, the previous script, and he might want to reuse it, or at least parts of it. And let's define a correction factor as a separate, that we can compute in a separate function. And the correction factor is only dependent of the distance, on the distance. And the default value could be 1. And if the distance is smaller than 1,500 kilometers, then it could be 125. Or if it's lower than 3,500 kilometers, then it could be 110. And then we can just return this correction factor. And then all we need to do is to get the correction factor by giving the distance and then just multiplying the CO2 emission by the correction factor. And he could also check that the values are correct that are provided to him. And he can say, okay, now let's submit. And we added some deliberation. And if we look at the script, we see that there are now two options, one with a correction factor and one without. If we go back to the item, the algo results did not change because both scripts have the same amount of votes, and the first script is still being used. And of course, this flight is actually a long distance flight. So the correction factor would be 1, and therefore the value would not change at all. But let's make a different version. And let's say maybe Paris and Roma. And for the distance here, I could say 800, but I'm not sure about the truth. I didn't check. Okay, let's add the version. Here, the algo result says that it's 88 kilograms, approximately. But we can have a look at the tool. And maybe we want to request a vote, specifically about the correction factor. I will switch to the tools to see better. And let's say that the person completely agrees with the first option. So he can submit the vote. And now, as we can see, there are two votes for the first option. And if we go back to the Paris to Roma travel, well, we have a completely different value. We have 110 kilograms. So even after defining products and their processes, we can still vote on the script and we can update the algorithms. If we get more people to vote on the airplane tool, at some point, the tool will produce consensus on a script, and a given script can be considered to be effective or selected. And here, for example, we had 5 votes for one option. And this is enough to agree on this script and to mark it as validated, accepted. And so we see it as green and accepted.